how can I write and graph linear functions using slope-intercept form, point-slope form, and standard form? So I'm going to start out with what's probably the most annoying or hardest to work with form, and that's standard form. So that's this one here. Then we'll go to slope-intercept, which is my personal favorite, and point-slope form, which is a bit less commonly used. So standard form is where you have a linear equation written like ax plus by equals c. And a, b, and c could literally be any numbers. They don't have really any specific meaning. They just have to be real numbers. That's it. So how do I write and graph linear functions? So this is just kind of like maybe you have a situation where this, the way it's described leads you to write something like ax plus by equals c, and that's fine. You know, sometimes say you're like selling tickets to a concert and you have x, which is adult tickets, and y, which is child tickets, and c, and so like a could be the cost of the adult, b could be the cost of the child, and c could be your total income. And you have to figure out how many adult and child tickets you sold. That's where you get with standard form. To graph it though, you're either going to change it to point slope or probably slope intercept form, or you might like make a table of values or just substitute in a couple values. What I like to do is substitute 0 in for x, see what y equals, and substitute in 0 for y and see what x equals. And doing so is a bit simple because if I put 0 for x, a times 0 is 0, so by equals c. And if I substitute in 0 for y, I end up with ax equals c. And it's easier to solve for that one variable, assuming you have a, b, and c. That's standard form. Now, let's get to an easier form to work with that I prefer, and that's slope-intercept form. This is one of the more common forms of a linear function you're going to see. Y equals mx plus b. M is your slope, all right? B is your y-intercept. So say I have a graph in slope-intercept form. Well, here's my graph. I can see I have a y-intercept at 0, 2. So the y-intercept is 2, which means your b value is 2. Slope is rise over run. In this case, my rise is going down, so it's -1. And my run is 1, so I go down 1 over 1. So m equals -1 over 1, which equals -1. I can then substitute b and m into y equals mx plus b. So I can write the equation y equals -1x or -x plus 2. That's the equation for that line. Now, how do I graph this line? Well, y equals 1/2 x plus 3. I start with the intercept. I go up 1, 2, 3. So when x is 0, y is 3, I plot that point. Now I use the slope to plot a few more points. Really, you just need one and a straight edge. So the slope is rise over run 1/2, so 1 over 2. So I go up 1 over 2. You could actually go down 1 and back 2 if you wanted as well. Up 1 over 2. I plot a point. I then connect these together, and I draw a line. And that is my line y equals 1/2 x plus 3. Point slope form. For this one, you're going to need a y-coordinate and an x-coordinate from a point on the graph, and you still need the slope. So, in this graph, it tells me the slope is 1, m equals 1, and one point is labeled, meaning I can write the equation in point-slope form. So, if my slope is 1, and my point is 2, 4, so this would be x sub 1, and this is y sub 1, and I just substitute in here. So I do y minus 4 equals 1, so I can just put 1, I guess, times x minus x sub 1 is 2. Right? Now, keep in mind that the equation, the formula has it with minus, so down here, when I'm graphing this point slope form, I need to know y plus 2 is really y minus -2. So that means that the y-coordinate would be -2, and the x-coordinate, -3, would be 3. So to graph this, I plot the point 3, -2, 3, -2, 1, 2, 3, 1, 2. Then I use the slope. This slope is -1/3, so I can go down 1 over 3. Down 1, 1, 2, 3 over 3, and I plot a second point. Now that I have the slope, I have one coordinate, and the slope, I use that to plot a couple points. You can use a straight edge, draw a line right through those 2 points, and that's generally what this line would look like. Again, very quickly, that's how to write and graph linear functions using slope-intercept, point-slope form, and standard form.